Thank you, Gavin, Preeti, Sumit, and Michael. That was a thought-provoking discussion. Interesting views on the future. Space exploration, zero-touch mining, digital twin, agile supply chain. Wow, that's an impressive list. Challenges that lie ahead. ESG, can we walk the talk? Future skills. I reckon we'd better start upskilling. Moving on to the next chapter. Next up is Coert du Plessis to talk about machine learning, automation, and humans. Having had the pleasure of working with Coert, I can certainly vouch for his contagious energy and passion for change. Coert du Plessis is CEO of the world's leader in productivity outcomes for open pit mining, MaxMine. Previously, Coert led BHP's global digital transformation, Innovation Mine, and BHP's global data strategy and agenda. Prior to BHP, Coert was a senior partner with Deloitte, leading the data analytics practice, specializing in machine learning and application in energy and resources. Coert is often described as 100% passion and 100% relentless drive, making up the 200% energy needed to sustain lasting change. He's a regular keynote speaker, avid angel investor, and a scale-up mentor. Over to you, Coert.
Thank you very much, Anak. What a nice introduction, and great to see you again in this digital format. I'm just so happy to be here, guys. Thank you for sending me this invite. Like, I was up last night at 1 a.m. and I'm going, these guys are so smart. I better put a bit of extra content. So I'm warning you, I'm going to go a bit fast. It's there goes my microphone. Sorry, guys. This is the second time this has happened. Every time the recording starts. There we go. I'll see if I can. Right, that should be better. So I've got quite a bit of content I'm going to go through. And I just want to say I really enjoyed the whole discussion with all the alumni from IIT I've met before. It's an institution, I believe, that still teaches critical thinking. And, in our industry, that is so important. So let me get into some of the content I want to get you through. So I started on a farm a long time ago. I grew up, didn't even speak English. And my mom brought in a box of cables. Inside that box was a VIC-20 computer. Most of you won't even know what that is. That's the thing you used to plug into the television. That would give you about 3,500 bytes, not kilobytes, bytes of memory. And if you wanted to save your game or your work, you had to put it on a cassette. And that's how I learned actually English, is actually from a computer manual writing BASIC. Now, something interesting about the VIC-20 computer is it's the same computer Elon Musk used to code on. And Elon Musk has something very interesting to say about automation and humans. And that's the topic what we're going to explore today in the short case study. Humans and automation are better together. They're not one off against each other. And so here's the quote that he put out, famously trying to ramp up about 3 years ago, the Model 3 ramp up, and they had lots of challenges with that. Don't underestimate humans. And if we just kind of switch over to the tech side and we go the other way, Bill Gates, if you automate something that's really working well, you get great results. But the opposite is true. If the things aren't working well, you run into trouble. Now, Elon Musk was struggling with automating a complex manufacturing plant. But mining is about 2 to 3 orders of magnitude more complex than a manufacturing plant because of the high variability that's innate in it. You talk to anyone in mining and they will complain about the challenges of knowing what's happening on their side. Let me give you a quick example. So our software segments out haul roads, which the trucks drive on. This is an automatically segmented 500-meter piece of haul road. The speed limit here is 60 kilometers an hour. What do you think the speed is that the trucks who goes hundreds of times a day through this section, one direction, what do you think the speed variability is? Now, we don't have an audience here to ask questions, so I'll give you the answer. It's 25%. The average speed is 38, all the way from 18 to 53. But let's translate that into value. In mining, as you guys would have heard, we can sell everything that's made. People need these resources to build electric cars, to make jewelry. And that is 25% less tons. And notwithstanding all of the amazing technology advancements, those results are recent. That's not some change that we've had from a few years ago. And operator variability exists in many places. I've talked to you about the speed of the trucks, which means that we burn a lot more fuel, massive CO2 emissions that we can reduce. Fill factor is how full we load the truck, so the dig units that load the trucks. Every time a truck runs with space on it, it's an opportunity for improvement. And also adverse events. These are like really like going Ferrari and racing into the corners or going too fast down a hill, and you actually risk damaging the equipment. So there's great operator variability, but it's not just operators. The machines are complex. There's 16 different haul trucks just in our system that we look at, and 14 load units, graders, water carts, dozers. And each of those have unique combinations of things being put together. They are ultimately very complex machines. They're not that many, but they are complex. So you've got hundreds of different combinations of variability. And then you have variability in scale. Both those bears are diggers. And, you know, as an aside, if I was on a rocket ship today, or whether I'm riding that big lever on the right there, you'd feel pretty powerful. Those are very impressive machines, and I've had the privilege of sitting in them and watching the good operators work. You feel definitely like you're on top of the world. Now, when I talk to startup CEOs and people in the mining industry, people tell me miners hate technology because it's so hard to get technology into mining. And I tell them it's not true. Miners don't trust technology. And there are three barriers to this trust. Let me take you through each of them. Let's just start with value. There's still a very strong love of technology, trying to bring that technology to a solution. I love VR. My kids play it. I've got a whole Vive headset set up upstairs with the whole room. And it's really good for immersive training. In fact, it's very good for safety experiences. But how often have I been in BHP or other customers now where someone has strapped a VR headset onto a general manager and virtually walked him around his mine site, showing how impressive this metaverse is we've built. But that's not how someone wants to work with these people. That's not a good use of technology. The value there hasn't been solved. So find the value. The next one is data. And because of the great variability in mining, especially around what we don't know what's in the ground, that means it's really hard to plan. But also lots of competing pieces of information. We have two kinds of situations that happen. Good people's work aren't recognized well enough because we measure everything on a mine site. And then we have conflicting information. It's incredible how many things get measured digitally, analog, various data forms that are connected. And you kind of have this new thing, like we've got bred a whole new kind of species of operator that knows how to play the data game and kind of play the data off against each other to get the right story. Neither of those are good outcomes. And for those of you that have kind of like know me a bit, one of the challenges for me is lasting impact. So just over a decade ago, we used the Kahuna network, some AI neural networks, and we predicted who's going to get hurt next. Who's going to get hurt next in the mining industry? Because if I can predict what you're going to buy next, likely on Amazon or on eBay, I can predict likely what's going to happen next to you on a mine site. And we were 70% right. And you talk about career disappointment, this is one for me, because I couldn't go and say, hey, Coert, don't go to work tomorrow. We think you're going to have a fatigue event. We haven't solved how we translate that knowledge into impact. There's a whole bunch of barriers to using personal data to help people be better. We have to solve that trust problem. And that's the lasting impact. Incredible analysis, way ahead of its time, inability to use it. So let me talk to you about data trust. If you really look at a mine site, it's really got a natural rhythm to it. Those trucks are like conveyors. Mine sites are huge. I mean, if you think about BHP's Escondida, which is one of the largest copper mine holes in the world, one-way traffic is 40 minutes for a truck. And we've got this is a site in Western Australia that I just put up there. So you've got this rhythm and you can automate that rhythm. So let me just kind of click through. So for those of you that are a bit technically minded, we collect data at very high resolution, about 50 hertz, you know, and we don't lose anything. If we lose connectivity, which is a big variability problem, we store all that data. And we push it through a sausage processing machine that really focuses on data quality, and then we gamify it on the other end where the operator is. Now, we treat all human input as error. So we have human inputs that tells us what the thing does when the truck or the digger or something is off. That's an error. We need to fix that. We need to improve. And we have humans, engineers, students that help us review our algorithms. I'll show you now. And whenever they fix or label something, that's an error. So we treat all those items as error in our training. For those of you that are in the kind of geeky space, I just put up a few of the things we use, and they change every few months. So that's and you can write lots of rules around how the truck should operate and what they're doing, and you can classify it. But you really need AI and some really good data quality processes, high resolution data, to deal with all of time. Like one of our leading developers says, all of time is a lot of time, and you find weird stuff. And so that's where we use people. And I don't know if some of you guys follow Tesla. They have this dojo where they train their cars to do better. Well, we build a canary because we have so many of those configurations to deal with. So this canary tests hundreds of combinations of trucks and dig units and so on. So we can get to those data quality elements. And it simulates GPS movement and so forth. Okay, let me just go forward because I'm on a tight timeline here. When you get to value, what I mean with value isn't like how does the tech become value? I mean, you've got to start at the value side. So what you're seeing on the screen is a standard value driver tree in mining. And each of those levers translates to profit and loss of the business. You can pick any of these and get value, but every site will have a unique set of circumstances about what that value is. So for example, it could be get more tons on a truck because that's our biggest problem this month or this quarter. So that's what I mean with value. And let me just show you kind of how that translates. So this was a customer a little while ago. They had poor loading conformance. If you put too much on, you damage the equipment. If you put too little on, you waste opportunity. And so within about 3 months of working with our coaching team and kind of the technology and really good data measurement, we got that from 10% to 70% conformance. But the truth is that you don't need software to really do that. People with stopwatches and really smart coaches can do that with limited data, traditional capturing. What makes this approach unique is that 14 months later, we got even better results. There's no way you would have gotten that bump up with software alone. You've got to think about the human in the loop. And when those coaches normally leave, you revert to mean. So this is where humans and computers work together the best. Now, let me just kind of close off on trust. This is the one I'm really feel passionate about. Just another speed example. So the software automatically segments a piece of road because we tend to blow up the roads or you put explosives somewhere. And so the trucks or the diggers have to drive a different road. So we did this again. And in the mining industry in Australia with our closed borders, we're hurting for software engineers and data scientists. We're also hurting for truck operators. And what has meant there's a lot of turnover in the industry. It's not just software engineers that are constantly turning over. It's also operators. And when you get to a site, you have to learn how that site works. When your speed drops, the performance of the whole mine site drops. The trucks can only drive as fast as the slowest operator does because they bunch, they create a queue. So within 2 months is our current rhythm. We can get new drivers up, invert the Pareto, 80% of the drivers into top 20% of performance. And that's a massive uplift. And there's a whole bunch of benefits for it. But the thing that really matters, and I think a lot of the people that we work with, is about how do we have these operators that are often managed on averages have their best days. And this is where gamification comes in. When we have those league tables and people trust the data and their management backs them because we are pulling a value lever, then we make a real difference. When we compare those trucks on a segment, it's the same type of truck that's carrying the same weight because it makes a huge difference to speed. On the same road, on the same shift, because weather has a huge impact on speed. And for those of you that have gone go-kart racing, you know that some go-karts are faster than others. We check engine power. So that those things are truly a fair comparison. All those things happen automatically in the background, just so we can get those smiles on people's faces when they get top of the league and then they coach the rest of their team. I want to leave you just with a few thoughts. When we started the innovation mine at BHP, I was privileged to lead that, and it's now called the Digital Factory. There was a mine manager there called Paul Oakley, and he said, "Coert, hurry up. Every day our people get so much better, and we're destroying the business case of value that you bring to us." And I want to leave that challenge with you. Help us make mining better because our people deserve it. It's interesting because I think they're actually more open in many ways. The challenge with automation, and if you want to Google, I did a talk a little while ago on the 7 lessons I've learned from automation at BHP. It's on SlideShare. There's a video somewhere for it. But the challenge with automation is actually that the processes need to be mature. The truck's road conditions and road management needs to be good. And people all think it's about the trucks driving themselves. That's actually easy. It's actually the lack of processes that are not in place. But the biggest challenge for automation is that there's 88,000 pieces of surface equipment out there, so 88,000 big pieces of mining equipment, of which 50,000 are surface trucks, big ones, 90 tons and above. And only about 800 last year were automated. You're not going to dump these $4 to $6 million trucks just overnight. And so for mid-tier miners, they tend to have a lot of the sunk capital. And for them to find the capital to buy new trucks or retrofit existing trucks is hard. And so I don't think that the miners or the mid-tiers are resisting automation. Roy Hill's going that way right now. The issue has been that humans can improve so much. If you get a 25% human uplift, then you destroy the business case for automation. And we've seen that happen a few times. The mid-tier guys are really chomping at the bit to go automated. The risk, the internal processes aren't mature enough. You are doing interesting work in, do we have the skilled people? Look, we have incredibly skilled people right now. I think what we sometimes lack is actually good leadership that can understand what the real problem is in mining and translate that, because it's not the same space as factories. The capability of people I've seen in Australia or Silicon Valley or in South Africa or in China that we've worked with is incredible. It's actually a leadership challenge, I think, in translating what the real focus is, understanding that it's not a perfect world when we build this software. So I think the skills are there. Probably the bigger one is, as I've said previously, we've lost about 250,000 migrants into Australia a year on the skilled program. The universities have stopped taking or haven't been able to get as many international students in, and we've lost a lot of expats. So Australia's got an unprecedented skill shortage, and the booming business means there's massive demand. So I think it's just a number of good quality engineers that we have, ones that do critical thinking. Security. Yeah, I think security is probably one of the areas where adoption has been difficult. I think COVID has accelerated the connect direct to the internet methodology that miners haven't had before. And so I think that the security measures are becoming more and more important. I think the biggest risk is really what happened with the pipeline right now, and that's around ransomware attacks on the edge. As we kind of remove that air gap where very old computers, some of them still run Windows XP on some mine sites, are now more and more required to be connected to shared data. That is a real risk. I don't have a straight answer other than saying we have to stay ahead of the game here, because the only way to improve the productivity is to actually add more connectivity. And the risk with that is that you open up a few more pathways. There's a lot to be done. We take security very seriously. We run a lot of closed loop networks, but there is always risk. Thanks very much.